The astrolabe is a device that was used historically for astrological purposes, star locating, and navigation. The word is originally derived from the Latin and Greek words astrolabium and astrolabos, meaning essentially star taking. The astrolabe is a device that, though being ancient, is still often used for basic astronomy education today. Not only can it be used for astronomy, the device can also be a lot of fun in other contexts, for things like detecting the height of an object or following the pattern of the sun's altitude. Astrolabes are an ancient device, and like most devices or inventions, they were invented out of necessity. In the time that the astrolabe was created, the stars were an important part of many religious beliefs, and the solar system was just becoming realized by scholars. Navigation also became important to people, and the astrolabe was used for that later on in its history. Astrology. The study of the movement and relative positions of celestial bodies, interpreted as having an influence on human affairs and the natural world. Astrology inspired much advancement in the science and study of stars. The Apollonius, the great codifier, was the first to invent the mathematic equations behind the device. Hipparchus, who also discovered the precession of the equinoxes and was influential in the development of trigonometry, redefined and formalized the mathematics. Hipparchus did not invent the astrolabe, but he did define the projection theory behind it. No one knows when they actually came to be as a device, but John Philoponus of Alexandria in the 6th century was said to have used a device arguably astrolabe-like. Astrology was an important part of early Islam, when a piece of technology was introduced that assisted in the astrological efforts and also allowed them to find specific prayer times in the direction of Mecca. The Arabic scholars took it into their own hands to develop the astrolabe further. The astrolabe was a great tool for them and developed into quite beautiful and complex scientific devices. It's possible that the astrolabe was in Europe as early as the 11th century, but it wasn't made popular until Christian monasteries distributed the knowledge in northern Spain. Popularized in the 13th and 14th century, the astrolabes were imported with Arabic inscriptions. This is believed to be the influence of the Arabic use in the naming of the stars. The European adaptations of the astrolabe didn't include references to Muslim prayer times and were instead replaced with other astrological features and had adaptations for time measurement in that era. Astronomy was a primary part of education in the 15th and 16th century, and the astrolabe was one of the primary tools for astronomy. The popularity of the astrolabe declined in the mid-17th century and continued to fall until the 19th century. What can you do with an astrolabe that makes it relevant for your science project? Become a quick owner of an astrolabe first to find that out. The paper versions are easy to come by, and it's 1, 2, 3, so simple to make. Find instructions online with the links in our bio to become a proud owner of the astrolabe. All you need is a bit of trigonometry to make this device work for you. It's great for determining the height of objects within your view. The straw located at the top of the model pictured is used as a telescope for your viewing pleasure. Look through the straw and locate the top of the object you wish to determine the height of. Are you in a building? Try locating the top of the wall furthest from you. Or, if you know there's a tree outside, take a walk outside and find the top of that tree. You're going to need a friend for this next part. Measure your distance from the tree in feet. Measure your steps. Each step is a foot. Then, take your astrolabe and look through it to reach the top of the tree. As you're looking through your straw to see the top of the tree, the string pendulum will move and mark an angle on your astrolabe. Have a friend record that angle for you. Grab your smartphone and open a scientific calculator. Type in the angle your friend recorded and press the tan key. Then divide that number you get by the distance between you and the tree. Make sure to add your height to that number. That will be the height of the tree in foot measurement. You can also use your astrolabe to find your latitude. To find your latitude, you use similar techniques as you used in the previous exercise. You will need to locate Polaris, the northern star. Go outside at night. Polaris is the brightest star in the sky, directly above the edge of the ladle in the Big Dipper. Google it. Through your astrolabe, locate Polaris. Once you have it in your scope, have a friend record the angle displayed on the astrolabe. Take the angle your friend recorded. That is considered your zenith angle. Finding your latitude is just a few quick steps. Take your zenith angle and subtract it from 90 degrees. Whatever number The result of that is your latitude. If you're in Canada, your latitude will most likely be between 40 and 70 degrees. Try detecting the changes in the sun's altitude. This is an activity that you can do as a research project. It's something that astronomers would have done when the astrolabe was at its most popular point. This activity will not have you looking directly at the sun because it's dangerous for your eyes. Instead, you'll point your straw towards the sun and place your hand underneath the astrolabe. Move the straw until a circle of light lands on your palm. The straw will be pointed directly at the sun at that point. Record the angle on the side of the astrolabe. Repeat this daily and at the same time of the day to see if the angle, which is the altitude of the sun, changes at all. What ancient astronomers discovered is that depending on the season of the year and how close you are to the equator, the sun would move across the sky in different patterns. Now that you've learned what an astrolabe is, what it's used for, and how you can use it, give it a try. Find a friend. There's links in the description for more resources.